So we're going to look at a video lesson here on 8.3, which is about proving parallelograms. We're going to use what we know about parallelograms and basically do the converse of our original statement. If the following characteristics are true, then a quadrilateral is a parallelogram. That's the converse of the statement we're going to go with. So we look at our first box here. If both pairs of opposite sides of a quadrilateral are parallel, then that quadrilateral is a parallelogram. Now this is the converse of the original definition of a parallelogram. If a quadrilateral is a parallelogram, then both pairs of opposite sides of that quadrilateral are parallel. So, how do I determine if a quadrilateral is a parallelogram? If I know ABCD, quadrilateral ABCD, is a parallelogram, based on this picture, that's because AB, or I'm sorry, not in this case, not AB. We're going to look at quadrilateral in this picture, which is QRSP. QRSP is a parallelogram because the opposite sides, QP, is parallel to RS, and both pairs, PS, would then be parallel to QR. So because those opposite pairs of sides are parallel, then that quadrilateral must be a parallelogram. One of our other properties said if both pairs of opposite sides of a quadrilateral are congruent, then that quadrilateral is a parallelogram. So now we have a picture of a quadrilateral ABCD. We know that quadrilateral ABCD is a parallelogram because this four-sided figure has opposite sides that are congruent to each other. So AB would be congruent to CD, and AD would be congruent to BC. So in last video lesson 8.2, we were given parallelograms, and then we could use those sides and set them congruent to find missing side lengths. Here, we have to determine, because these sides are congruent, opposite sides are congruent, then I know it's a parallelogram. It's kind of working backwards, if you want to think it that way. One of our other characteristics was that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is also a parallelogram. Now remember, if I can prove one of these is true, that's great, but if it makes one of them false, then the rest obviously are going to fall out of place. So I have to check to make sure that I can prove one of them to be true, because if they are true, then it is a parallelogram. So looking at this picture here, I can see that angle C is congruent to angle A. I can tell that B is congruent to D. And since in the quadrilateral ABCD, I know is a parallelogram, because the opposite angles are congruent, meaning because angle A is congruent to angle C and angle B is congruent to angle D. The last one kind of ties in what we know about the angles and sides. We don't need to know every single thing about if both pairs of opposite sides are congruent or both pairs of opposite sides are parallel, if we can assume that if one pair of opposite sides of a quadrilateral are parallel and congruent, not both, just one pair. If I just have one pair of opposite sides that are parallel and congruent, then that quadrilateral is also a parallelogram. So in this picture here, we can see that the information that they give me is all about BC and AD. And because BC is congruent to AD and BC is parallel to AD, in that same side, I can say then quadrilateral. It's a bad quadrilateral symbol there. A, B, C, D is a parallelogram because BC is congruent to AD and BC is parallel to AD. So, recapping here just as a class, let's just look at all of them for 1 second. Looking at these 4 different converses, we can kind of use that information to help us determine if a quadrilateral is a parallelogram or not. 1, 2, 3, 4. We are going to add a 5th to this, and it has to do with the D in cooties. So if you remember back from 8.2, when we talked about the 5 properties, we also had this property, the D in cooties, which had to deal with the diagonal. So let's go ahead and look at that now on the next page. If I flip back to the next page of my note packet here, if I know that the diagonals, and the diagonals are line segments that cross through the quadrilateral, and they go from one vertex to an opposite vertex. If the diagonals of a quadrilateral are bisectors, meaning they bisect one another, are bisectors, then the quadrilateral is a parallelogram. This is usually a tougher one for students to identify or use to prove if a quadrilateral is a parallelogram, mainly because it takes the knowledge of understanding where the midpoint is and then being able to find segment lengths. So let's go ahead and just look at this specific example. Since this segment is congruent to this segment and this segment is congruent to this segment, that point where they intersect is obviously the midpoint. And I can go ahead then and say in quadrilateral AB, CD is a parallelogram. And why? Because AC, segment AC, and segment BD bisect each other. The only reason I would know that is because they gave me the tick mark saying that those two segments were congruent. One thing I failed to mention on the previous page, so we'll go over this now. If I'm looking at this on a coordinate plane or graphing it, on a graph, if you were trying to determine if they bisected each other on a graph, you would kind of look for or use the midpoint formula. And if you can, kind of think about what that midpoint formula is. Some of you remember it using your x1 and x2 and y1 and y2. Also, we kind of talked about SAD, stack, add, divide by 2. So if you are looking at it in a graph, you might want to use the midpoint formula to determine if that point right here is in the middle of those two segments. So let's go ahead and flip back to the previous page just for 1 second. And let's think about it here. When we're talking about lines being parallel lines on a graph, to determine if two lines are parallel, you're going to look to use the slope formula. Because if the slopes are the same slopes, then you know the lines are parallel. If we're looking for congruent, opposite sides being congruent on a graph, then we're going to want to go ahead and use the distance formula. Because the distance formula helps me figure out the length of segments, or the length between ordered pairs on my graph. Again, if we're trying to find opposite angles that would be congruent on a graph, then we must look to see if all angles add up to 360 degrees. If I know these two angles and these two angles, you're going to have to use kind of look at and determine if all the angles, and see if they add up to 360 degrees. If they don't add up to 360 degrees, then we're probably not looking at something that is a quadrilateral and therefore a parallelogram. Last but not least here, because these are congruent, we can use the distance formula. The distance formula on a graph. And just as a quick reminder, the distance formula is looking to find the distance, and that would be the square root of the distance, the difference in the x's, plus the difference in the y's, and I'm going to square those differences. When I square them and add them, that helps me find the distance between 2 points. Alright, so now I think we can go ahead and jump into some review problems as a class. So let's go ahead and look at number 1 here on the second page of the 8.3 notes. These are examples of problems that are all mixed up using the 5 converse theorems we just learned. And all they're asking us to do here is determine if the following quadrilaterals are parallelograms. If they are, we just kind of have to state the theorem of why. Alright, so let's go ahead and look at number 1. Number 1 is giving me information about angles. And if I remember back to Cooties, the only one that deals with angles is dealing with the opposite angles. Actually, consecutive angles are supplementary, but the opposite angles have to be congruent. This tick mark means that this angle is congruent to this angle, they're opposite, and 100 is equal to 100. So since opposite angles are congruent in this picture, I can say yes, and the reason being, the opposite angles are congruent. And I'm using some shorthand notation here just to kind of lighten up on the writing. This symbol means angles, this symbol means congruent, but yeah, that's how we're going to determine if it's a parallelogram or not. Looking at number 2 now. Here they're giving me, it looks like side lengths. They tell me that this is 20 and this is 20, so wouldn't that make those opposite sides congruent? And this is 14 and this is 14. So when I look at the opposite sides being congruent, yeah, this would be another example of yes, this is a parallelogram because both pairs of sides are congruent. Both pairs have to be congruent in this case. Looking at number 3, these segments that kind of cut through my quadrilateral, those would represent diagonals, and since the diagonals look like they're broken up into 2 smaller congruent segments, this would again be a parallelogram because the diagonals bisect each other. So again, all I'm doing is pulling this information from the top of this page and the previous page of our notes and just seeing which postulate or which theorem kind of matches up with the problem that's in front of me. Looking at number 4 now, they tell me something about this segment, they tell me something about this segment, they tell me that both those pieces are parallel to each other. They also tell me that they're both 30 meters long. So since that one pair of opposite sides is parallel and congruent, I can say yes, this quadrilateral is a parallelogram. And the reason is because one pair of opposite sides are congruent, and let's shorthand this, congruent and parallel. Congruent and parallel. Number 5, let's look at number 5 together here. 7 inches, opposite sides congruent. 5 inches, opposite sides congruent. Since I have both pairs, yep, this quadrilateral is a parallelogram. And it's because both pairs of opposite sides are congruent. Look at number 6, our last example here. Again, if you're catching on, you feel like you're getting this, go ahead and pause the video at any moment and just kind of try the problem on your own. Again, try it and then watch the video and see if that makes sense. So last but not least here, they're giving me angles. They tell me this is 65 and this is 65, meaning they're congruent. This is 115 and this is 115, meaning that those opposite angles are congruent. So yes, this is a parallelogram because both pairs of opposite angles are congruent. So 1, 2, 3, 4, 5, 6. Let's look at number 7. The quadrilateral WXYZ is given to me. They tell me that angle W is 42 degrees, angle X is 138 degrees, and angle Y is 42 degrees. Find the measure of angle Z. So if this, find the measure of angle Z, and once we find that angle Z, let's see if this is going to be a parallelogram. Explaining the reason, we're going to have to determine if the opposite angles are congruent. That's basically what we're going to have to get to. The first thing you always want to do is draw a picture. We're very visual learners. It's much easier to understand what quadrilateral WXYZ looks like if we can draw a picture. So let's kind of just sketch a quadrilateral. It doesn't have to look like a parallelogram. It might be helpful to do that. They tell me that angle X is 138 degrees. They tell me angle W is 42 degrees. WXY would be over here and Z would be down here. They tell me that Y is also 42 degrees, and they need to know what the measure of angle Z is. We need to find that measure. So since this is a quadrilateral, back in 8.1 and 1.6 we talked about if a shape has 4 vertices, then the sum of the interior angles is going to be 360 degrees. So the measure of angle X, 138, plus the measure of angle W, 42, plus the measure of angle Y, 42, plus the measure of angle Z is going to add up to 360 degrees. When I go ahead and add up 42, 42, and 138, and I subtract that from 360, I end up with the measure of angle Z being equal to 138 degrees. Now, because Z is 138 degrees, we can realize that in our picture that the opposite angles are congruent to each other. And since the opposite angles are congruent to each other, we can say that WXYZ is a parallelogram. Run out of space there. Because the opposite angles, both pairs of opposite angles are congruent. Two-part question, we found measure of angle Z, and then we applied what we knew about the four angles to determine if that quadrilateral was a parallelogram. Looking at our last example here for number 8, for what value of x is this quadrilateral MNPQ a parallelogram? We need to find the value of x which is going to make this quadrilateral parallelogram. So when I look at the pieces that are given to me, they tell me that this segment is congruent to this segment, and they tell me that this segment right here is equal to 2x, while the other half of that segment, that diagonal, is 10 minus 3x. So since they're giving me the diagonals NP and QN, it looks like they're trying to prove that this is a parallelogram because the diagonals bisect each other. So they're looking at the converse, they're saying if the diagonals bisect each other, diagonals of a quadrilateral, bisect each other, then the quadrilateral is a parallelogram. That is the converse statement they're trying to prove true. To make this statement true, they need to make sure that the diagonals bisect each other. The only way that's going to happen is if the sides, after the intersection, the two segments are congruent to each other. So the last thing I need to know is, does 2x equal 10x minus 3? And when I solve for x, I do find a value of x that will make those two segments congruent to each other. So as long as this equation is true, then I can say that they bisect each other, and therefore this quadrilateral is a parallelogram. So I'm going to go ahead and add 3x to both sides and get 5x is equal to 10. When I divide by 5, I realize that x is equal to 2. So when I plug 2 in, that makes this segment 4, and that makes this segment 3 times 2, 4. So are they congruent? Yes. Do the diagonals bisect each other? Yes. Therefore, because x equals 2, C-A-U-S, because x equals 2, then, or not because, let's say if x equals 2, then quadrilateral MNPQ is a parallelogram. Excellent job. Very good. Let's go ahead and turn to the very last page here of our notes. And we're going to look at an example of a parallelogram, possibly, if it is on a coordinate plane. Lots of SOL questions are like this, so I'm going to make sure that we really focus in and understand this question. We really want to make sure we understand how to do this type of problem, because more often than not, it will show up on your SOL. So we're going to double star this guy, because this is a great SOL question. So we're going to prove this quadrilateral ABCD is a parallelogram. To do that, we need to find something important about this picture. We really have two options. We want to show either that the slopes, we want to show equal slopes, because if the slopes of opposite sides are equal, that means that the sides are parallel. We're going to write this at the top of our notes just so we can kind of have a point of mind from the beginning of our notes. If they have equal distances, that means sides are congruent. That means sides are congruent sides. So if I can use the distance or slopes of this quadrilateral, that might help me determine if these lines are going to be parallel perpendicular or parallel, or equal, and then that will show me that I have a parallelogram. So let's first try to find some slopes here. Let's find some slopes. In green, we're going to find the slopes of all the different segments. We're going to find the slope from A to B. We're going to find the slope of A to D. We'll find the slope of B to C. And we'll find the slope of C to D. Remember, to find slope, it's all about rise over run. So as I go from A to B, I'm going up 2, and I'm going right 1, 2, 3, 4, 5. Up to right 5 is going to give me a slope of positive 2 over 5. Let's go ahead then and look at the side opposite of that side. So opposite of AB would be CD. So let's see if this slope is also up to right 5. So 1, 2, 1, 2, 3, 4, 5. Yes, this slope is also to 5. So if the slopes are congruent, that means that my lines are parallel. Let's just, for measure, let's look at AD and BC. If I go from A to D, I'm going down 1, 2, 3, and then right 1, 2, 3. So since I'm going down 3 and right 3, that's going to have a slope of negative 1. When I look from B to C, 1, 2, 3, 1, 2, 3, that also has a negative 3 over 3 slope, which also simplifies to negative 1. So these lines are also parallel to each other. That alone can prove that that shape, ABCD, is a parallelogram. But maybe if you're not a slope person, maybe you're more of a distance kind of guy. So if you want to use the distance, or the distance formula, then you would want to go ahead and find the segment lengths. For example, AB and CD. And I'm picking AD and CD because those sides are opposite of each other. And if I can prove that they're congruent, and I already know that AB is parallel to CD or BC, then I know that I have a parallelogram. Because only one pair of sides needs to be parallel, congruent, to prove parallelogram. So to find the distance here, I'm going to look at the change in the x's. How far did my x's change? Well, from negative 3 to positive 2, that's a change of 5. If I do negative 3 minus 2, I get a negative 5. So I'm going to square that value. Plus the change in the x's, 3 to 5. How far did I change there? Well, I went up 2 spaces. So when I do 5 squared, I get 25. 2 squared is 4. And when I take the square root of that sum, I get the square root of 29. No point of simplifying that radical at this point, as long as CD is equal to the same length. So looking at CD, change in the x goes from 0 to 5, so that's a change of 5 squared. Plus the change in the y's goes from 0 to 2, that's a 2 squared. Well, guess what? That is also equal to the square root of 29. So that tells me that AB is congruent to CD. As long as I can prove that one pair of opposite sides are congruent and parallel, then I know that the quadrilateral ABCD is a parallelogram. My proof is in the pudding, and this is the work that would be needed to demonstrate the proof of a parallelogram. Let's look at 5. Let's kind of recap and look at 5 ways to prove parallelograms, and this is a great way to kind of recap at the beginning of the lesson. If I can show that opposite sides are parallel, if I can show that both pairs of opposite sides, I've got to make sure that's very clear about that, both pairs of opposite sides are parallel. If I can show parallel for both pairs of opposite sides, I got a parallelogram. If both pairs of opposite sides are congruent, I also know I have something that would create a parallelogram. The other way is with angles. If both pairs of opposite angles are congruent, then I know I have a parallelogram. The last one, or second to last one here, deals with the diagonals, right? The diagonals, and those diagonals bisect each other. bisect each other. Then I know that I have a parallelogram. And last but not least, if one pair of opposite sides are both parallel and congruent, then I know that quadrilateral is a parallelogram. So that kind of just recaps 8.3 and gives you a little insight on how to prove parallelograms. Make sure you revisit the notes if you get stuck and try the practice problems in your practice packet. Good job today.